This video is Storytime Killer Energy. So, I ended off with you doing a science experiment. And the answer to that science experiment is B. Remember those wobbling atoms on page 28? When you heat up the air in the bottle, the atoms have energy and try to move off in all directions. Think of a glass of energetic kids running outside at break time. Give me a second. My roommate is hot out there. There. Give me 1 minute. There. I was just getting hot in my bedroom, so I was just taking the covers off me. And there's more of the answer. The warm air atom push up the straw and they push the water up too. When the air is cold, the atoms have less heat energy, so they don't want to go anywhere. Think of kids huddling together for warmth on a cold day. The pressure of the air pushes down on the straw from above the water level down. So the hot air goes up, the cold air goes down. Bet you never knew. The plans of Galileo's thermoscope were amongst his papers when the great man died. Galileo left his papers to scientist Vincenzo Vivian in 1622 to 1703. But when Vivian died, his family thought the papers were worthless. They were rubbish. So they sold them to a local sausage maker to wrap his bangers. Then another scientist ate one of the sausages and read the writing on the wrapper. He bought the entire stock of wrappers, including this design for the thermoscope, and so it was that Galileo's great discovery was saved, thanks to a sausage. Galileo's discoveries, did they cost a packet? Yeah, a packet of sausages. Tricky temperatures fact 1. Scientists still had a problem. They had thermometers, but they couldn't agree on a scale to measure temperature. Scientists made up their own measurements, and this no doubt led to heated argument. Lovely day. Yes, it must be 90 degrees. You idiot, it's 60 degrees. If it was 90 degrees, you'll melt. So they couldn't decide on the degrees, but what number? 2. My hair looking weird. That got it. 2. The first widely used measurement of temperature was invented by our own pal Daniel Fahrenheit. Can you guess what it was called? Fahrenheit. 3. Fahrenheit decided that the coldest temperature he could make by mixing chemicals in his lab was 0 degrees. This meant that the water froze at 32 degrees. And the temperature of the human body was 96 degrees. I'm getting up Fahrenheit actually. That's 3 times 32 Fahrenheit. But Fahrenheit hadn't got it right. The body is around 98.6 Fahrenheit, so he carefully planned scale was wrong. In the UK, we do degrees. In America, they do Fahrenheit. Just so you know, so you don't get confused. Scientific note. He probably measured the heat of his armpit, and this was cooler than his mouth. Oh well, he meant no arm and anyone can make a mistake in the heat of the moment. Very sorry. Four. Fahrenheit scale is now used in the USA, but the rest of the world uses a measurement invented by a Swedish scientist named Andrew Celsius in 1701 to 1744. It's sometimes called centigrade, but the official name is the Celsius scale, after its inventor. Like I was saying before, US uses Fahrenheit, we use Celsius. What do you think? Oh, that's really handy, Andy. Andres was the son of professor of astronomy, and he grew up interested in maths and science. He loved exploring and went on 2 trips to the north of Finland. There he studied the northern lights and made observations that proves the Earth was slightly flattened at the North Pole. 5. Andrews suggested a scale of 100 Celsius, with water boiling at 0 Celsius and ice melting at 100 Celsius. Yes, you did read that right. Andrew Celsius put his scale the wrong way round, but another scientist reversed it after his death. Oh well, I guess they had a measured approach to science. But thinking about freezing, there's lots of freezing going on in the next chapter. In fact, the chapter's cold enough to freeze a cup of tea rock hard in 1 millisecond. Are you wrapped up really warm? And don't forget your scarf. Oh, Mum. And I'm going to read the next chapter tomorrow. And it's going to be in the same video, but for me, it's going to be tomorrow. So stay tuned. The chapter we are on now is the dead freezing chapter. And I'm just counting how many pages it is. It's 3 pages. Then the next chapter is 5 pages. So I'm going to read 3 pages tonight. Then the next one will be the rest of the chapter. You can skip to 11 minutes, 5 seconds if you want to skip all me talking on that bit. Skip to 11 minutes, 5 seconds. Going to be the next chapter. Then that will be all for this one. Then it'll be the next. Then after that, they're going to be then the next one will be 3 chapters, the next episode. And take 3 chapters is the next one. Then the one after that is another 3 chapters, so that's 2. 2 more episodes after this one. So there's 3 more episodes after this one. So there'll be about 4 before we get to near the end. There are going to be about 8 more episodes. Then the last one will be a quiz on what you learned. And that's going to be over 2 episodes. One is going to be all the questions, then the answers in the next one. And you can cheat. But I'm not that bothered if you cheat or do it or not. But on that one, I'll let you know that you can not listen to it. Or you can just listen to it and just not do the quiz, or to skip the last 2 episodes until I get to my next book. There are going to be about 4 or 5 episodes, then the 2 quiz one, then a new book. So, let's carry on where we left off. So, if you want to skip all me talking in this bit, you can skip to... Give me 1 minute. So, the dead freezing chapter we're on. If science leaves you cold, you might be gobsmacked to hear that science really can be cool. In fact, super cool. Yes, this chapter and the next one are about losing heat, energy, and the science of low temperature. The big freeze up. Remember the 3rd law of thermodynamics? The one that says that you can't get colder than absolute 0. Bet you never knew that one scientist who worked on this law went to university when he was just 10 years old. Whoa, just 10 years old. That young. Very young. Probably the same as the kids in primary school. He'd been dead for ages, but we've sacked him with energy for one last interview. Not actually possible, but in a storybook it is. So they brought him back from the dead. Dead Brainy, William Thomson, Lord Kelvin, 1824 to 1907. Welcome back to the land of the living, your lordship. It's good to be back. So that picture. So, what's it like to be dead? I'm buried in London in Westminster Abbey next to Isaac Newton. I'm happy to be seen dead with him. That picture now. You began your career by going to university at the age of 10. Well, I'm not one to boast, but school science was just too easy for one of my giant intelligence. Your first maths discovery was read to a science meeting by someone else. Why didn't you read it yourself? I was only 10 at the time. It must have been past my bedtime. So that picture. You eventually became a professor at Glasgow University. Yes, I was getting on a bit then. I was all of 22. And how long did you stick at this job? 53 years until I ran out of energy. So that picture and that picture. You studied electricity and heat and worked on the 2nd and 3rd law of thermodynamics. Yes, they were being hotly debated at the time. Using math, you calculated that you couldn't cool anything below absolute 0. Yes, it's known as Oh, Calvin. God name, eh? Good name, eh? Bottom two pictures. You advised on the laying of the first telegraph cable across the Atlantic Ocean and made a fortune. Yes, I was. Cable to answer every question. The top picture. Of course, you made some mistakes in your work. You claimed that the sun heat comes from burning coal. I wonder if it ran out yet. The next two pictures. But you never knew. 1. A degree on the Kelvin scale is the same as a degree Celsius. But unlike Celsius, the Kelvin scale starts at absolute zero. The scale is used for scientific measurement of the heat energy of atoms and is named after the great man became its suggested it. 2. Thomson was named Lord Kelvin for his service to science. He took his title from a small river in Glasgow. I expect the locals called it a wee burn. So today, scientists use the name of a wee burn in Scotland every time they measure temperature. Spot the difference. The Kelvin, a wee burn, a hot plate with a lot of Kelvin. Lord Kelvin with a wee burn. Those pictures. And that is all I'm going to read for this bit. So stay tuned for the next bit. I'm going to read it tomorrow, but for you it'll be in 2 seconds. See you in a bit. Sorry about the lighting, it just because the sun is in the wrong place. So, I'm going to be reading Welcome to the Chill Out Zone. And I'm going to read 4 pages. No, 5 pages actually, until I get to the next chapter. Then that will be all for this video, because I already filmed some stuff. So, let's start. Welcome to the Chill Out Zone. So, would you like to experience absolute zero? Almost. As close as they can get to absolute zero. Well, what you need is a holiday in space. Not gonna happen. Unless you're an astronaut. But you never knew. Away from the sun's heat, space is only degree or 2 above absolute zero. It's so cold that pee ejected from a space loo freezes instantly into a pretty stream of golden crystals. When you asked what the most beautiful sight he had seen on return, astronaut replied, the urine dump at sunset. For some chill-out scientists, this sort of thing is brilliant. They cool atoms for super cool experiment by trapping them with a magnetic force. Did you know that electricity runs through the chill-out atoms with scarcely any friction? Well, that's just the start of the weird stuff. Give me a second. Just turn off for a minute, because that noise was annoying me. I'm back now. The Ice is Nice Company presents Fancy a Cool Thrill by the super cool helium. It's the same cat that they put in high flying balloon, but is cooled to minus 272.2 degrees, minus 485 Fahrenheit. Amaze your friends and terrify the cat as it turns into a liquid and starts climbing the side of the jar. Cool. Give me a second, I just need to blow my nose. The small print. Don't drop your cat in the helium or you might end up with a frozen pet. Fancy an ice cream? Can't wait hours for it to freeze? Try using the super cold liquid nitrogen at 196 degrees, minus 393 Fahrenheit. In 1997, a British scientist used this substance to make ice cream in 10 seconds. Children who sampled the ice cream said it was very nice, and as chef said, it's not very rich or creamy, but it definitely tastes like an ice cream. The small print. The nitrogen won't spoil the taste when it meets air. It turns into nitrogen gas and floats away. And that's fine because air is mostly nitrogen gas. All of that picture there. By the way, if you're thinking about making the ice cream, you should know that if you stick your finger in liquid nitrogen, it freezes solid and breaks off. Don't do it, or you lose a finger. I guess that's what they call a cold snap. Or do I mean ice cream? But talking about dipping bodies in liquid nitrogen, did you know that some people are planning to preserve their dead bodies in just this fashion? Because they think they can unfreeze when they can fight off their illnesses. Fearless reporter Harvey Tucker is just about to find out more. Harvey Tucker's Big Adventure. I'm going to leave it there, but tonight I'm going to read the last 3 pages, then upload the video. Stay tuned. Thank you for watching. Bye.